They call it gravestone, and for good reason. The 92 and 6A radar, NATO codename Gravestone, is the brain, the eyes, and the nervous system of Russia's most feared air defense weapon, the S-400 Triumph. It is not simply a radar. It is the single most critical component in the most advanced surface-to-air missile system Russia has ever built. It can detect aerial targets at ranges of up to 480 kilometers. It can simultaneously track 100 targets and guide missiles at multiple threats at once: aircraft, cruise missiles, ballistic missiles, drones, in any weather, day or night, against adversaries using electronic jamming. Every launcher in an S-400 battery depends entirely on the 92 and 6A to function. Destroy this radar, and the entire battery, the launchers, the missiles, the command systems, goes completely blind. It becomes in a field with no idea what is flying toward it. And Ukraine has now destroyed it multiple times inside Russian territory at distances Russia considered completely safe, using drones that cost a fraction of what the radar is worth. This is not just a military story. It is the story of how Ukraine has spent 4 years methodically dismantling the most expensive and sophisticated air defense network ever fielded by a regional power, and why 2026 has become the year that network crossed from being degraded to being structurally broken. To understand what the destruction of the 92 and 6A Gravestone radar means in strategic terms, you have to understand what Russia's integrated air defense system was designed to do and what it now cannot do because of Ukraine's campaign. Russia built its air defense architecture on a principle called layered defense. Multiple overlapping, all networked together, all communicating, all feeding targeting data to each other, so that no aerial threat could pass through one layer without being picked up and engaged by another. The S-400 Triumph was the centerpiece of that architecture. With its 92 and 6A engagement radar capable of detecting targets at 480 kilometers, it served as both the longest-range interceptor in Russia's inventory and the backbone of the network's situational awareness. The S-400 battery's command system connects to Russia's broader integrated air defense network, sharing targeting data with short AR range systems like the Pantsir S-1, the Buk M3, the S-350 Vityaz, and the Tor M2, creating a seamless, mutually supporting defensive picture that was supposed to make Russian airspace impenetrable. Every time Ukraine destroys a 92 and 6A radar, it does not just blind one battery. It punches a hole in the entire network. The networked architecture that gives the integrated air defense system its strength becomes its vulnerability when individual nodes go dark, because the systems that depended on that node for coverage can no longer see what it was watching. The gap it creates is not just physical, it is a coverage void that no other system in the immediate area can fully compensate for, and it is a void that Ukraine can fly through on its way to targets that were previously protected. On March 1st, 2026, at 2:30 in the morning, 4 Ukrainian strike drones flew into the Tula region of Russia, approximately 180 kilometers south of Moscow, and attacked an S-400 air defense position in the settlement of Osanovaya Gora. The drones struck and caused substantial damage to a 92 and 6A Gravestone radar. The Tula region is not a borderland. It is not a contested area near the front line. It is deep inside Russia, the region that produces Russia's world-famous Tula gingerbread and samovars, home to the Kremlin's most important defense manufacturing facilities, sitting barely 180 kilometers from the capital. Russia had positioned an S-400 battery there precisely because it felt safe. The battery had been in the same position for an extended period. Russian forces likely kept the complex there because it was deep in the rear, as United 24 media's analysts noted, and that lack of movement, that assumption of safety, is what allowed Ukrainian targeting to build the intelligence picture and execute the strike. The Dossier Shpiona project, one of the most credible open-source intelligence channels tracking Russian military assets, confirmed the strike and explained the implications with precision. The 92 and 6A is a multifunctional station with a 3-dimensional radar and phased array antenna. It handles searching, detection, identification, and missile guidance. The entire battery, which includes 3 to 6 launchers, depends on the 92 and 6A to function. Disabling this radar effectively paralyzes the entire battery's combat capabilities, and these radar systems are high-tech and rare assets that are difficult to replace quickly. That last sentence is crucial. Difficult to replace quickly. Russia cannot simply order a new 92 and 6A from a warehouse. These systems are produced in small numbers at a single Russian production facility. Western sanctions have disrupted the supply chain for key components, and Ukraine is destroying them faster than Russia's production system can reconstitute the losses. The Tula strike was not isolated. It was part of a pattern of escalating radar destruction that accelerated dramatically in the first months of 2026. On February 25, 2026, Ukraine's Special Operations Forces Middle Strike Unit conducted a coordinated strike against S-400 positions in occupied Crimea overnight. The confirmed targets struck in a single operation included a launcher from the S-400 Triumph system, a 92 N6E engagement radar and its auxiliary components, and a Pantsir S-1 short-range air defense system that had been deployed specifically to protect the S-400 battery. Ukraine did not just destroy the S-400's eyes. It simultaneously destroyed the short-range system that was supposed to protect those eyes from exactly this kind of drone attack. Defense Express, one of the most authoritative Ukrainian defense analysis publications, confirmed the strike and the specific systems destroyed. The intelligence preparation and targeting precision required to hit a radar, the launcher it serves, and the protection system guarding it in a single coordinated strike represents a level of operational sophistication that demands serious attention. On March 9, 2026, Ukraine's Special Operations Forces conducted a series of strikes specifically targeting Russian radar systems across occupied Crimea. In a single operation, Ukrainian operators destroyed 4 radar installations, including the 5N84A Oborona 14 long-range early warning radar, capable of detecting aerial targets at distances of up to 400 kilometers at high altitude, and the 55 Pfizer 6U NIBO-U mobile radar complex, capable of detecting fighter-sized targets at ranges of up to 700 kilometers at altitude, and specifically designed to detect low observable aircraft, cruise missiles, and drones. 2 additional radar stations housed in specialized radomes near occupied Yevpatoria were also destroyed. 4 radars, 1 operation, 1 night. Each of those systems had been providing situational awareness over a different sector of Crimean airspace. Each gap their destruction created exposes targets that were previously under protective coverage to Ukrainian strikes that can now proceed without detection or early warning. The aggregate picture that emerges from all these individual strikes, compiled by OSINT analyst Clément Mollin and confirmed by United 24 Media, is staggering. Ukraine carried out 44 successful strikes against various Russian air defense systems in just the first 3 months of 2026. The complete list of system types destroyed includes multiple 92N6A and 92N6E tracking radars, the S-400's engagement eyes, the very rare 9S15 Imbir and 9S32M1 radars from the S-300V system, the 50N6E multifunction radar from Russia's most modern S-350 Vityaz system, 6 Buk systems including Buk M1, Buk M2, and advanced Buk M3 variants, multiple Pantsir S-1 systems, the Kasta 2E2 radar, the Podlet K1 radar, the 5N84A Oborona 14, the 55 Zeder 6U NIBO-U. 25 different radar system types destroyed, covering virtually every category of sensor in Russia's layered air defense architecture, from long-range early warning to medium-range tracking to the S-400's own engagement radar. This is not coincidental. Ukraine is executing what military doctrine calls a suppression of enemy air defenses campaign, CD, with a systematic comprehensiveness that has never been achieved before in the history of unmanned warfare. Traditional SEAD operations use crewed aircraft with anti-radiation missiles, flying dangerous missions against live radar emissions, accepting significant aircrew risk to destroy air defense systems. Ukraine cannot conduct traditional SAD because it has limited conventional aircraft. Instead, it built a drone-based CAD capability that is, in practice, more effective than any previous CAD campaign in history because it is slower, cheaper, more patient, and more relentless than any crewed aircraft campaign can sustain. Ukraine can send drones every single night. It can rebuild its strike packages faster than Russia can repair its air defense systems, and it can learn from each strike to improve its targeting of the next one. The broader statistics confirm how dramatically this campaign is reshaping the strategic landscape. According to Ukraine's Unmanned Systems Forces commander, in just the first months of 2026, more than 80 air defense elements were destroyed. In January alone, 21 systems were eliminated, 13 SAM systems and 8 radars, along with 19 portable radars and 3 electronic warfare systems. In February, the pace increased by 20%, 25 elements destroyed. In March, a further 36% increase, 36 air defense elements destroyed, plus 49 portable radars, and 1 electronic warfare system, each month more destructive than the last, each month opening wider corridors through Russia's defensive shield. The Ukrinform analysis summarized it with a sentence that should resonate through every defense ministry in the world. 2026 will go down in history as the year Russian air defense effectively turned into the most expensive scrap metal in the world. The SBU's Alpha Special Operations Center separately confirmed that throughout 2025, its operations destroyed or disabled Russian air defense systems worth an estimated $4 billion, and the pace has only accelerated in 2026. When you add the cumulative destruction of the entire campaign since 2022, the numbers reach figures that no defense industrial base could easily absorb. Ukraine War Analytics and ISW both confirmed that the total number of Russian air defense-related assets struck since the invasion began exceeds 1,300 documented systems. At the rates of destruction in early 2026, that total is compounding at its fastest pace since the war began. The strategic consequence of all this destruction reaches far beyond the specific systems that have been eliminated. Every radar that goes dark opens a specific geographic corridor through which Ukraine's long-range drones can fly undetected. The Nebo-U radar destroyed near Yevpatoria in Crimea was surveilling a broad sector of western Crimean airspace. Its absence means Ukrainian drones approaching from certain vectors can travel further before being detected by surviving systems. The 92 N6A damaged in Tula was covering Russian airspace at ranges that extended back into Ukrainian territory. Its degradation means Ukrainian aircraft operating near the border are less visible to Russian targeting systems in that sector. The 9S-32M1 radar from the S-300V system, destroyed in January 2026 with video evidence, covered an entirely different altitude and threat band. Its loss affects Russian awareness of a specific category of aerial threat that the S-300V was designed to address. Russia is attempting to respond. Moscow constructed a new ring of more than 100 Pantsir air defense systems mounted on specialized towers surrounding the capital. A defensive investment that reveals just how seriously the Kremlin takes the threat of Ukrainian drones reaching the Moscow metropolitan area. Russian forces are attempting to reposition surviving air defense assets more frequently to reduce their vulnerability to drone targeting. But repositioning creates its own problems. A system that moves constantly cannot build the stable communications links and integrated situational awareness that a fixed system can maintain. Russia is caught between two bad options: stay in position and be targeted, or move constantly and degrade the integrated network performance that makes the system valuable in the first place. Ukraine's targeting doctrine exploits exactly this dilemma by pursuing systems that have been stationary long enough to build a precise targeting picture, then striking before repositioning occurs. The long-term implications for the entire architecture of Russia's air defense are what analysts are calling a critical threshold moment. Russian air defense expert analysis cited by Ukrinform was direct. Russian air defense has degraded to the point where it is no longer capable of protecting not only national airspace, but even its own assets. A system that cannot protect itself is a system that is on an irreversible trajectory toward collapse. Each destroyed radar makes it easier to destroy the next one. Each eliminated launcher removes coverage that would have detected or engaged the drones targeting surviving systems. The degradation is not linear. It is exponential, because each loss weakens the network's ability to detect and respond to the next attack, which makes the next attack more likely to succeed, which causes additional losses, which weakens the network further. That is the architecture of what Ukraine has built and what Russia is now facing. The Gravestone radar, the most feared sensor in Russia's most feared air defense system, has been struck inside Russia in the rear areas where it was supposed to be safe by drones that flew through gaps in the very defensive network it was supposed to protect. Putin's air defense is not simply being degraded. It is going blind, radar by radar, system by system, layer by layer, in a campaign whose pace is accelerating precisely as Russia's ability to reconstitute its losses is slowing. The most expensive scrap metal in the world is accumulating across Russian territory, and Ukraine has no intention of stopping until the blindness is complete. Understanding what it takes to build a 92 N6A Gravestone radar is essential to understanding why its destruction matters so much beyond the immediate operational loss. The system was developed by NIDAR, the Scientific Research Institute of Long-Range Radio Communications, as a core component of the S-400 program that Russia's defense industry spent nearly 2 decades and billions of rubles developing. The 92 N6A features a phased array antenna using digital beam steering technology that allows it to track multiple targets in different directions simultaneously without physically moving the antenna. It operates in the IJ frequency band, specifically chosen to be effective against the full spectrum of modern aerial threats, from low-flying cruise missiles to high-altitude ballistic missiles. Its upgraded 92 N6A variant was specifically engineered with enhanced anti-jamming and signal processing capabilities designed to remain effective even against sophisticated electronic warfare, the kind of countermeasures Ukraine employs extensively. It entered service in 2007, has been exported to Algeria, Belarus, China, India, and Turkey, and represents the absolute cutting edge of Russian air defense sensor technology. Each system takes years to produce, requires specialized manufacturing infrastructure that is now partially degraded by Western sanctions, and incorporates components that Russia has been struggling to source since 2022. When Ukraine destroys one, Russia cannot go to a warehouse and pull out a replacement. The production queue for S-400 components was already under strain from the pace of the war before Ukraine began accelerating its SEAD campaign in 2026. The SBU's assessment that air defense systems worth $4 billion were destroyed in 2025 alone represents a financial and industrial loss that Russia's defense production capacity, running at 7% of GDP and already stretched to its limits producing artillery, drones, and armored vehicles, is not equipped to quickly absorb. The Ukrinform analysis observed this directly. Russia's ability to defend its territory is approaching a critical threshold increasingly, with the demands of its vast geography. Russia's air defense replacement capacity cannot keep pace with Ukraine's destruction rate. The gap is widening every month. The arrival of French Mirage 2005 fighter jets in Ukraine's Air Force adds a dimension to the radar destruction story that connects the CD campaign to a larger strategic picture. These are 4th Generation Plus aircraft equipped with advanced digital avionics. Ukrainian pilots confirmed to the Air Force that the Mirage 2005 can intercept Russian cruise missiles and Shahed attack drones with a 98% success rate. The aircraft can also deliver AASM hammer-guided bombs and Storm Shadow cruise missiles. As Ukraine's CD campaign continues destroying Russia's radar network and opening ever wider corridors through Russian airspace, the operational value of aircraft, like the Mirage 2005, increases dramatically because those aircraft can now fly into regions and engage targets that a fully intact Russian air defense network would have been able to detect and engage at range. The radar destruction campaign is not just protecting Ukraine from Russian strikes. It is preparing the operational environment for a future phase in which Ukraine can operate more freely across the entire theater. The human dimension of what Russia's radar losses mean at the unit level is something that rarely appears in coverage of air defense warfare, but is critically important to understanding the real-world impact. When a NATO N6A radar is destroyed, every officer and soldier in that S-400 battery does not simply stand down. They are suddenly operating in a world where they have no idea what is flying toward them. The system that told them how far away a threat was, at what altitude, at what speed, from what direction, that system is gone. They might hear explosions nearby. They might receive fragmentary reports from other units. But the precise, continuous, electronically processed situational awareness that a modern air defense battery depends on for its survival, that is gone from the moment the radar goes dark. And in an environment where Ukrainian drones are flying every night and can appear with almost no warning, operating an air defense battery without its engagement radar is not just ineffective, it is dangerous for the crew. Russia's response to this crisis reveals the depth of the panic it is creating in Moscow's military planning. The expansion of the Pantsir Ring around Moscow, more than 100 systems on specialized towers, is not the action of a confident military command that believes its outer air defense layers are holding. It is the action of a command that has concluded its outer layers are unreliable, and is building the innermost ring of a defensive system that has been progressively stripped of its outer layers by Ukraine's SEAD campaign. The capital is being surrounded by short-range point defense systems because the long-range early warning network that was supposed to provide strategic depth and reaction time can no longer be trusted. Russia is retreating from strategic air defense to terminal defense, from defending a vast territory to defending a shrinking perimeter around its most politically sensitive location. That retreat is a military concession of historic significance. The Ukrinform analysis that described 2026 as the year Russian air defense effectively turned into the most expensive scrap metal in the world is not rhetorical. It is a precise description of what is happening quantitatively, qualitatively, and structurally to a system that Russia spent decades and tens of billions of dollars building. More than 80 air defense elements destroyed in the first 3 months of 2026 alone. 44 successful strikes in a single quarter. 25 different radar system types eliminated. The 92 N6A Gravestone, the most feared radar in Russia's most feared air defense system, struck inside Russian territory in a region that sits 180 kilometers from Moscow. And the pace is accelerating by roughly 36% month over month. Putin built his air defense network to make Russia impenetrable from the air. Ukraine is dismantling it, sensor by sensor, system by system, corridor by corridor. The Gravestone radar is gone from Tula, the Nebo-U is gone from Crimea, the Oborona 14 is gone from Yevpatoria, and every gap their absence creates in Russia's aerial picture is a gap that Ukraine is already using to fly deeper, strike harder, and open the next corridor for the strike that comes after. Putin's air defense network is going blind, and the most expensive scrap metal in the world is accumulating faster than Russia can dream of replacing it. What the gravestone's destruction represents, beyond the immediate military calculation, is something that should reshape how the world understands the trajectory of this war. Russia's air defense network was not just a military asset. It was the physical expression of Russia's strategic depth, the network of sensors and interceptors that gave Moscow the ability to monitor, react to, and defend its vast territory from aerial threats. It was the system that made Russian airspace a place where hostile aircraft could not easily operate, where long-range strikes required careful planning and accepted significant losses, where the Russian interior felt genuinely protected from the consequences. Of the wars, Russia chose to start at its borders. Ukraine's SEAD campaign is not just eliminating individual military systems. It is erasing Russia's strategic depth, converting the vast Russian hinterland from a protected rear area into an exposed theater where Ukrainian drones can reach targets that Russian military planners considered permanently safe.